Again, good evening, everyone. So I heard everybody is able to listen into the audio and video without any problem. So let me know if you run into any issues. I hope we don't have any problem today, but also I am on the Wi-Fi network today. I'm not on my LAN network, but in the past also I never had issues. So let us see how it goes. In any case, just to going back to what we have covered and what we are going to cover today. It's going to be we're adding a new concept here. It's called dimensional modeling. That is going to be the topic that we are going to use in terms of designing data warehouses in Kimball approach. Also, if you talk about Inman approach, some of the concepts will work even there. Okay, so if I look at the previous lectures that we have covered and compared to what we're going to do today, it's slightly different. And again, what I would like to do is, going back to what we learned in lecture 3 and lecture 2 and lecture 1. So we had a lot of questions. It's really interesting. Really appreciate all your questions. It's, we have, we're able to share some of my answers and also get a good feedback. I saw Bit's team already uploaded the video. Okay, I see already some people complaining that the audio is not right. So let me get closer here and see if my audio, if I can change anything. So everything is good on my end. Okay, so just give a check mark. I would like to go through that. Give a check mark. You don't have to type anything. So if you hear the audio is good. Okay, so if I get majority check mark there, then we can continue here. Okay. Okay, looks like perfect. Okay, great. Okay, we'll move. I think those of you who are having a slight issue with audio, like we always have, it might be on your end if the majority of them are able to hear. So what I would do is, preferably I would ask you to exit and come back in. That might resolve the issues that you have. Okay. So let's move forward. Like I said, the previous lecture that we have covered gave a very high-level view of this course, and I'm sure some of you already got an idea what we're talking here. We're not talking about smaller scale databases. We are talking about very large databases. And sometimes some of your colleagues or friends in the class yesterday pointed out that they have seen 1.5 terabyte size table. So it is common when we are dealing with very large databases and very large data warehouses spanning multiple years of historical data. Okay, so if I look at it very high level, what we learned in the last 3 lectures, a very high level summary. We introduced the data warehousing. We have introduced some of the main gurus in this field and different methodologies they have introduced in this space. And then we said, both methodologies work good depending on the organization, depending on the situation that you're going to deal with. But you need to step back and then visualize what is your needs of the organization and then make the right choices. And then again, I also said in the last lecture, we talked about different architectures. So when we are coming up or designing an architecture, we got to be very careful that, when we say we're going to use hub and spoke model, or we're going to use the, conformed dimensional model, where the Kimball approach, where you're going to build the different data marts. And there was a question yesterday asking, okay, if I want to get the information from both data marts, and I have clearly answered, there are 2 answers. One answer is building another data mart to meeting those needs. Okay, that is when I go to that solution is, when I see there's a lot of users looking at the data, merging from 2 different data marts. So when that happens, then, that means we have a lot of users trying to pull the data from 2 different sources and trying to present online. So in order to make things faster, make efficient process, what I have recommended is build a new data mart. But we should not think immediately. As soon as we get a request like that, oh, we have a data mart here, we have a data mart here, we have a data mart covering North American data, we have data mart covering Asia Pacific region, and somebody comes in and say, oh, I have visibility, I need to have visibility in both regions, so I don't want you to give a conclusion as soon as you get a request. Okay, we can build one data mart. As a designer, we can do it. There's no question about it. But we need to make a right decision, a right choice. So that is where the experience comes into play, and then how we're going to make the decisions in the designing aspects of your data warehouse. So we need to be very careful, and then we also talked about slightly on the scheduling aspect. Scheduling is going to be touched extensively when you're talking about ETL, because that is where we're going to spend time, how we're going to extract, when we're going to load. We're going to talk about all those points. But for me, I want you to have a clear picture by now that data warehouse is a secondary system. This is not a primary system that gets the data real time. Okay, so you need to have that clearly built in. I'm sure there are some users, there are some business units that they would like to have real-time data feeds into data warehouse based on the needs of their organizations, but the percentage of those kind of data warehouses are very small, and I'm sure everybody wants real-time data in the data warehouses, but you got to be realistic, because as we see here, if you have seen my design before, we have already introduced the staging area, and then we're going to move to the next stage. Okay, so it means we need some time to process the data, bring into the staging, and look through whether data is coming correctly, are we having issues, make sure the data is cleansed before it gets loaded into the data warehouse tables. So all these steps will take time, so the amount of window that we have for the batch processing is very small, depending on the hours of operations your organization is dealing with. So it is very important for us to spend time, design properly your schedule, the batch schedule, in such a way that you're able to finish all the data loads in the available batch window when the users are not available. Okay, by the time users comes, everything should be updated, it should be available for reporting. And always, always again and again, I'm telling you, so we got to be very clear on our thoughts. In that aspect, saying, if somebody comes and say, oh, I have executed a transaction yesterday, it is not in my data warehouse today when I run the report. Okay, my immediate reaction to that question is, can you tell me when the transaction is posted in the online system? If that person says, oh, it's posted around 8:30, one of my users was working late and he posted a transaction 8:30 last night, and I was expecting that to be available here in the data warehouse when I run the report, my answer immediately to that is, if I know what I have done, my design, if my cutoff time for the data load is 8 o'clock in the night, and any transaction that happened after 8 o'clock, it will not be available for the reporting next day. It will be available reporting the following day. So, as soon as each person says 8:30, you don't even have to go and look at the documentation. You don't have to look at the tables. You don't have to look at anything. You know that that data might be sitting in the staging area, or it might not even pulled from the source system because you have a cutoff time of 8 o'clock. Okay, so those are the things that we've got to be very clear, in our decision making, in our communication. So people in the business unit should have a clear understanding on this in this aspect, so that it's easy for you. Otherwise, it's going to be a nightmare, and everybody will be complaining, and every time you're going to spend, and then at the end of the day, go back and say, oh, sorry, we missed the batch schedule. That's why your data is not there. So that's why I was telling this kind of information should be kept, communicated, kept in the metadata, so that you don't have to explain that to everybody. You can just tell that, okay, guys, you go look at the metadata. You have all this information that is how our schedule is running. You don't have to come and ask me when the data is available. If transaction is processed before 8 o'clock, and if it is not available for reporting, then come to me and I can investigate. Okay, so it is, those are the things that I hope you have clarity by now. And if you don't have a clarity on these aspects that we have covered, I know we touched a lot of other points, but at least I want to have these points clearly understood by now. Okay, I see one question here, Manoj. I run load code every 30 minutes instead of nightly schedule. Yeah. So Manoj, again, like I was telling you, you could run any load jobs into the BI. I can also run the load jobs in one of my data warehouses. I run real-time updates into BI, but those real-time updates stay in the staging area. That's it. They're not going past the staging area until my nightly schedule runs. So it is a way that you design. We're going to talk about all those points as we get into the ETL. So depending on the design, depending on the architecture that you have, you make a choice. I will run the real-time updates, but up to what stage? I don't want to run. So there's another important point, Manoj. That's a good question you asked, which triggered me right now. I'm telling you, there is another important point for me when I'm running the data warehouse is, let us say I run a report at 8 o'clock in the morning, okay, and it gives me data that report is showing me that the sales for whatever criteria that I put in, as of today, if I run a report, it gave me a sales of, for the last week, it gave me a sales of $10,000. And then somebody comes and run a report 4 o'clock in the afternoon, okay, and then it will give different numbers if you run every 30 minutes. So unless until you're giving this information clearly updated in the metadata saying that my report, my data uploads are happening every 30 minutes, and so if you run a report in the morning and if you run it later, so depending on the data changes that happens in the real-time system, so your reports will be changing. So, if you tell that information clearly to the business and they all understand, that is fine. But still, the problem for me is typically as we're dealing with these large tables, when a user is running a report and you're trying to update from the behind the scenes, that means you got to have a very, very large, what we call as in the database terminology, they need to have enough redo log space, enough temporary storage space available so that you can roll back transactions and you can do all those things when you're trying to run. If you are running a very long query that takes 10 minutes, okay, and in that 10-minute time, if somebody tries to go update the table, you might have issues. That is a typical database behavior. Okay, I'm running a query that is taking 10 minutes, and somebody comes in, update the same table within the 10-minute window, then your query that you have executed for 10-minute long query, the results will be looking different within the time span of 10 minutes. So what the DBMS, the database management system, will do is it will throw out an error for you saying the read consistency. Okay. So in order to avoid this read consistency errors, it's not a true error, but it is a read consistency because you are allowing the database to update while somebody else is reading a very large query. Okay, so you might have issues with those kind of issues. So that is the reason also I'm telling, if it's a small data warehouse and things will go really on the fly, there's no problem. But if you have very large data warehouse and your queries are running long and you know very well that on average a query runs 5 minutes or 3 to 5 minutes range. So if that is the nature of the data warehouse, this data warehouse that you're dealing with, then I would not update database tables during the day because you will have issues like this and then you have to answer when you have issues like that. So instead, you be clear, your data warehouse is a day lag reporting, period. And, but as long as, again, I'm telling you, in my experience in the last 15 years, all my data warehouses, only one data warehouse will try to do real-time updates. Again, I have insisted this is not going to work, but the business pushed me and escalated. So I said, okay, we will do one additional update during the day, in the middle of the day. So that is the only thing that we allowed. And then after we did that, after probably 2-3 months, the business came back and said, PC, that's fine. We don't want the middle of the day updates because I have cautioned them when I'm doing this update, I don't want anybody using the database. The database is completely off limits for you. The 2-hour window, the whole data load will happen. And then after that, I will give the communication back to you. Then you can start using. So when the users told me I can start at noon, and then database is not available sometime 2:30. So then some users already left for the day. It's just not going to work. Okay, unless it's a very small data warehouse, and then things will fly, and then you can update everything in 30 minutes or something like that. Still, I don't recommend that, but again, the business dynamics is going to play here in your decisions. So again, it's a good question, Manoj. I think I'm hoping everybody understands the reasons why we say data warehouse is 1 day lag when we're reporting the data, but I'm sure the management appreciates even 1 day lag. They don't care about it. They don't, because again, you got to look at it in a bigger picture. Most of the data warehouses serve strategic decision making. What is strategic decision making? What means, I'm sure it will be used for operational reporting. It will be used for day-to-day reporting, but I would recommend, I would strongly insist, the data warehouse should be really useful if you're using a data warehouse for strategic decision making. In my view, that means you're using the data, comparing previous year sales, previous quarter sales, and you're coming up with new promotions that you can generate revenue, new revenues for the company. You are using some past historical data to promote new products in a specific region based on the sales of other region. All those things, those are strategic decision making that is going to generate revenue for the organization. It's not a report that is there just for your day-to-day operations. Like, I need a report, okay, what I need to print, I need to produce the products and things like that. Okay, that is one kind of report. But for me, the amount of money that we're spending on investing in data warehouse, it should also return on investment is going to be generated with the help of these kind of decisions made by the vice presidents, decisions made by the top executives, looking at the data from the previous year and the previous quarter, previous month, the comparative sales. These are the things that are very important. Okay, so hope it is clear by now. Those are the points that I would like to highlight. By now, at least you should have a clarity on these aspects. Now we're introducing a new concept called dimensional modeling, which is going to be the topic for our discussion in the next few lectures here. And then also we have a case study that we're going to touch quickly here. Okay. So with that, a dimensional model, what is this? I think, again, it's mainly taken from a Kimball approach. So if you look at it, an alternative to normalized data model. So again, you can see here, we talked about normalized databases. So again, data model is a database design. So we have seen all OLTP applications are normalized data models. And in case of Inman approach, we will have part of the data warehouse is going to be a normalized data model, and then after that, we're going to go to the next step by denormalizing the data, creating a star schema and things like that. So, the main goal of this normalized data model is presenting the information as simple as possible, easier to understand for the business. It's very important for me because look at this. I said in the last lecture, I have seen a data warehouse with over 1,000 tables. And I think one of your friends in the class also attested my point, and they said, that person, I don't remember the name, but he said he has worked in a data warehouse, or he has seen a data warehouse with over 1,300 tables. That is the reality, okay? But for a business perspective, I don't want to tell, or I don't want to give that picture to the user, okay? This is what the data warehouse modelers, this is what the IT people will know, but from a business perspective, we will present a model that is so simple and it is so clear for them, so that they can understand. Just by looking at the data model, a star schema, they should be able to tell what all things they can do. They don't need to go back and look at what staging schema is, what staging is, tables are there, what is the data store organization, what is the ODS, what is the fact table. We don't have to worry about all those things. Very simple. If I see this, I'm going quickly jumping here. Just want to show you, and then we go back there. But if I see this star schema here, okay, there is a fact table in the middle. You have a date dimension, you have a store dimension, you have a product dimension, and a promotion dimension. So this is the view that I will give to the business users. Probably I will give this particular view a big printout and give it to the business user. I will ask them to hang in their meeting rooms, hang in their workspaces, so that they know just by looking at this, they should be able to tell what the data warehouse can give them at the end of the day, what the data warehouse can give the results to them just by looking at this. Okay, I'm sure some of you in the class will be able to explain this. So I would like to give an opportunity here if anyone would like to speak and explain what you understand by looking at this star diagram. Anybody want to speak? I would like to just raise your hand or say that unmute. I can unmute you so that you can speak. Just tell what do you understand by looking at this. There's a fact table. There's a dimension table called product, promotion, date, and store. Can you see anything? What do you think? By just looking at this, what do you understand? It's a simplistic view for sure. Okay, and Ayush Singhal. Okay, I'm going to unmute. Go ahead, Ayush. Try to speak. Ayush, I have unmuted you. See if you can speak. Okay, so there is a problem there. Okay, sorry. Anyone else who would like to speak? Okay, Michael. Okay, and Pawan. So I'm going to give a chance to Michael. Okay, go ahead, Michael.
Hi, Pisti, can you hear me?
Yes, it's clear now. Go ahead.
Okay. So what I understand is that we are trying to get probably from different places based upon the date and time from the different stores, what are the different products and promotions. So all those on the right side and the left sides are the key tables, but what is in the middle is the actual dump from all these kind of stores and everything. And probably we could just join it using a standard relationship and try to get it either store wise, what kind of promotions or and what's the period. So if I want to know from a store wise left side, let's say for the last quarter, I could join them and try to get this one. That's what at least I can understand.
Perfect. That's good, Michael. Excellent. I think that's a good explanation. Let me open up Michael, Pawan also. Let me see if you can give any different thoughts on this. Pawan, go ahead.
But I hope you can hear me, PC.
Yes, I can hear you clearly.
Great. Right. So the fact table looks like it's a dump of data coming from different OLTP-based database data tables. And then the data store, product, and promotions looks like they are the views that are associated with this fact table.
Okay. Okay, that's fine, understand. But what do you think you can run? What kind of reports you can run out of this? Because as a business user, I would like to see, by looking at this, I should be able to tell what I'm going to get out of this. Like Michael said, he said, yeah, I can run a report out of this by what sales in a quarter, last quarter a particular store has done. I think that's perfectly right. What else you can see from this? Just by looking at this, I'm not even looking at anything else. By giving a star schema for business user, assuming I don't know anything about computers, I don't know anything about tables, I only am a business user. I know how to run the report. I know how to create a report using a BI tool. That's all I know. I don't know anything behind the scenes that's going on in the data warehouse. So what do you think you can get out of this picture?
So I could, probably filter based on the dates that we have, given range, what kind of products were sold. I mean, assuming that these are products that were sold, and I could, filter based on a date range and try to figure out what product did best, what product sold the most, probably get a count of things or something like that, and probably go to even the promotion view there and try to find out which of the promotion paid well versus those which did not. So that kind of data probably is what I could pull out of this star schema model.
Perfect, excellent. Okay, that's good. I think I think those of you who are listening to Pawan and Michael, I think they have. I'm not told anything about this. I just gave this picture. They are able to come up with what this can give. Okay, so that is how simplistic view that I would like to give to the users, saying, okay, I have given this star schema. In my assumption, what I'm going to say is, so by looking at this, the fact is having all the actual measurements that my business is going to be measured on. Okay, what sales I'm doing, what is the sales dollar amount, what is the cost of the products that I'm selling. So these two will give my gross profit, what is the margins that we are making out of this product sales, So now with this information, I'm joining to dates, store, and then product, and then promotion. I have not given the attributes here, and depending on the attributes that you see here, like I said, I will give this complete picture to my business users. That means all the attributes that are there in the product, all the attributes that are there in the promotion, all the attributes that are there in the store, all the attributes that are there in the date. I'm going to give it to them so that they can hang the picture in their office space, in the meeting room, wherever there is. That will give them a clear picture. I can, at any given time, I can find out what sales a particular store has done on a particular product category, on a particular promotion, on a particular date range. I can join all of these things in one single query. At the same time, in the same query, I can also compare what I did in a particular date range from this quarter compared to the previous quarter. Okay, this date attributes also will have quarters, months, days, weeks, fiscal year, fiscal month, all of those things will be there. In the store, I'll have a store data like a store state, store address, store district, store region. So when I see that, then I can see what sales I did in this region compared to what I did in the other regions. Okay, that means I might have when I say I go by a particular store, I can get the analysis, but at the same time I have 10 stores in District 1, 10 stores in District 2, and if these two districts are joined, grouped as a Zone 1 or Southern Zone, so when I run a query, what my sales in Southern Zone, that means it will pull all the sales of District 1, District 2, that means 10 stores in District 1, 10 stores in District 2, everything will be combined, and then I will show the sales at the regional level. At the same time, I can also look at, for that regional level, what promotions I did, what products I sold in that region. Okay, then once I know in this region I'm selling these product categories, okay, what the same period in other region, what products are sold. Okay, now I'm thinking, I'm sure you're getting the idea here. So all this analysis is going to help drive new ideas. Okay, so that is the beauty of data warehouse here. Okay, so these are the things. Okay, I don't expect people to run a report thinking, okay, I'm going to go to the office. Okay, I'm going to run this report and I get the results and I'm going to work on that. I don't expect people to think and come to work and then start running the reports. These are the ideas. They come as they see the data, as they see the model. So usually they create the reports, they run the reports ad hoc basis. So which means we need to give a tool in the hands of a business user. They can do all those things. I don't want them to come to me every time they want to run a report. Or PC, I want to run a report from this product, this region, this promotion. They should be able to do themselves. Okay, so they run the report, they looked at it, oh, this data is not good. Okay, let me change the parameters a little bit. They run the report again, they see that. So when they're doing these multiple iterations, different views of the same data, again, if you ask me, the data is not changed. The data is same. We're not changing the data at all. Data is static. The views that you see, different views, different dimensional views are going to be different based on the dimension that you're trying to pull the data out of. Okay, so that view sometimes when they're seeing different things like this and they're playing with the data like this, suddenly they get a figure, okay, this is what is happening here. Oh, then immediately they will say, okay, 2014, this quarter sales were good, 2015, this quarter sales dropped. Then they start going analyzing why the sales dropped. Then they might go outside the data warehouse and talk to people and find out, okay, can you tell me the reasons behind? Was there an economic reason? Was there any problems due to natural disasters, whatever it is? Or is it a problem with our company or our sales guys are not doing good? Whatever it is. So these things will generate more questions. And then they try to investigate and they come up with a solution so that at the end of the day, company will be moving in the right direction so that they can generate more revenues. Okay, so look at this. That is where you need to generate this kind of clarity with the business users. Okay, so when they're spending a lot of money on the data warehouse designs, they're also getting a return. But if you ask me, PC, can you tell me return on this is? Can you tell me that okay, at the end of first quarter? after going in live with the data warehouse, within 6 months I'm going to give return on investment. I can't tell that. It also depends on how good your users are, how good they understand to drill down the data and extract the data in different views and play with the data and come up with some strategic decisions for the organization. Is that going to happen in 1 month? Is it going to happen in 6 months? It all depends on how good the users are, how intuitive they are to deep dive into the data and try to analyze the data and things like that. So there's a lot of things will play, but for sure I'm hoping by now. So when I said simplistic view, this is the view I want to give, and I don't want to give anything. And to get this view, I might have 500 tables behind, but that is my headache as a data warehouse architect, or as a data warehouse designer, as a data warehouse manager. That is all my problem, how to manage all the data, present the data in such a way so that as an end user, you can do n different ways of analysis. Okay, so hope it is clear for you now. So that is what I meant here, simplistic, as simple as possible, and then it will be easier for the business to understand. Okay. So the next question is return the queries as quickly as possible. Okay, this is again a tough point to understand, we contradict ourselves. We try to put as much data as possible in the one table. At the same time, we're challenging ourselves to give quickly the data out of the table for users. Okay, so that is why I'm telling you, you got to be very careful when you promise something to the users. So you need to be very careful. Like I think someone said here, I run my updates every 30 minutes. Okay, it might be a smaller data warehouse, or you have some kind, I don't know what the design that you have in your data warehouse. But if I'm allowing the 30-minute updates, that means I'm also taking another challenge onto myself, that the example I gave a few minutes ago. So there could be some read consistency errors. We need to address those things if the reports are taking longer. So those are the points that we need to be always remembering whenever we are trying to commit something to the users. So our goal is to give as quickly as possible, but at the same time, if the data volume is larger, you're trying to do a lot of analysis with the data, you also need to clearly explain the business, because of this, the report is taking 2 minutes. The report is taking 5 minutes. The report is taking 10 minutes. I have seen reports running 10 minutes, okay? So that is common in the data warehouse. But if every report is running 10 minutes, then there's a problem. But if there are some reports that has a complex in nature in analyzing the data and the volume of data they're crunching, if it is taking 10 minutes, I can explain, and I have an argument for that. But if every report, if every user is experiencing 10 minutes, then there's a problem there. So we need to address that. So that is what I would like to say, common sense here. Okay, so don't don't take some of the statements I say. I might be speaking those things, but again, you need to step back and then realize in a different way. So track the underlying business processes. Again, this is a very important thing. I've been telling again and again. In a data warehouse, data mart, if you are building something, try to be as clear as possible to try to stay within a business process. Don't try to mix things, okay? So you could always say that, okay, I want to put everything in one place so that I don't want to have business users going different data marts and different data sources, and it's going to be confusing them. They have to go for this place for one data, this place for other data. And like I said in the last lecture, you don't have to worry about it. You can always combine them in a BI tool. Okay, a view can be created in the BI tool and present that view for the users, and they will be happy with that. So, I think the point that I was trying to make here is, again, you have to have a clarity on what you're building. You need to understand, that, okay, the reasons why you're building in such a way that, and then you present to the business user so that it is as simple as possible for them to understand, and then they need to understand what they're going to get out of that data warehouse, and then all the struggle that you do is going to be behind the scenes, and then you work to make sure you get the results as quickly as possible based on type of data, based on the processing that they're doing, okay? Then coming to the next point, It contains same information as a normalized model. Okay, it has a far fewer tables. Okay, I'm contradicting to myself again from yesterday's point. So I said it has far fewer tables. What does that mean? It will be very simple, a smaller sized data model. Okay, so as you have seen before, I said in my data warehouse I have 1,000 tables, but from a business perspective, I'm only presenting very few tables. Sometimes I might have shown like what I showed you, like 5 tables. That's all it is. So for them, the data warehouse is only those 5 tables. That's all. So they don't need to understand all the tables that are behind the scenes processing and getting to that point. So in my view here, a far fewer table means I'm talking about purely, strictly the dimensional model where I have dimensions and fact tables. That's all I'm talking. Okay, so grouped in coherent business processes. Again, you can see here. It is going to be, what I'm trying to say here is again, I'm telling, don't mix up business processes. You try to stay within your business process and then build something. And for sure, as I said, it will be far fewer tables than the OLTP database. Only if you're looking at dimensional model, that's all. I'm not talking about entire data warehouse. I'm talking about dimensional model that you have seen, that you're going to present to the end user. So that is going to be very smaller. That has very few tables, but entire data warehouse still will have more tables than your OLTP system. Okay, because we're introducing staging area, we're introducing intermediate table, we're introducing a lot of other things. Okay, we might be introducing some summarized tables. So, for sure, if you compare with the OLTP database, you will have, for sure, more tables in your data warehouse. There's no question about it. But when I say this point here, I'm only talking about the view that I'm going to present to the business. Okay? So pre-join hierarchies and lookup tables resulting in fewer join paths than fewer intermediate tables. So what is this sentence here talks about? So that is what I'm telling, the statement that I said before, I'm trying to give the results faster. How am I going to give that? I might be doing some pre-joins beforehand based on my user behaviors, based on my user request. If I know that I have 100 users and 80 of the users are going to run this query every time joining these 2 tables, then I better pre-join them, present in 1 table instead of putting them in 2 tables, and every time they run the query, they join on the fly. So those are the things. You pre-join some of the tables and then put them available, physically available on the database so that they don't have to join on the fly when they run the reports. Okay? So another interesting point is normalized fact table, denormalized dimensional table. You see the interesting point here. So as you have seen the star schema just a few minutes ago, the table in the middle, the fact table, is a normalized table. So what is the concept of normalization? The one simple term I said yesterday, somebody asked, I gave a very simple definition: normalization, denormalization. So can somebody type there? Normalization means the data is not duplicated, no redundancy. Excellent point there, Chetan. Good job. Denormalization means we will have some redundant data there. If we understand that very high-level simplistic answer, that is good for us. I know we need to go deep dive, but at least you need to understand some of this terminology as we get along with this course. Okay, so a normalized fact table, in the sense, I don't want the repeated data there in the fact table, but I would like to introduce some redundant data in the dimensional table. Again, we'll talk about the reasons why we are doing that. But fact table, I don't want to have any redundancy, because there is also another point I would like to highlight here, is a fact table is going to have all the historical data over the years. A fact is a sale in case of sales data warehouse. A fact could be a claim in case of a claim data warehouse. Okay, so what's going to happen is, if I'm having a sales, that means if I'm going to keep my data warehouse for 10 years historical data, that means I will have 10 years worth of sales transactions. I don't want to have any duplicates, because If a sale is a sale. If I have a transaction, I go and buy a product online. Let us say I go and buy some online product, and I have one sale. And let us say tomorrow I go and buy another product, I have another sale. I cannot duplicate those things. If I duplicate and create and store in my sales stack, that means I'm artificially inflating the data. So there is no way we are going to do that. A sale, whatever is happening in the OLTP system is what we're going to bring in, and we're going to store it. So that's why most of the fact tables are normalized as much as possible, and the dimensional tables are denormalized. The reason why we want to denormalize is because the dimensional tables have all the descriptive attributes. When I say descriptive attributes, let us say I have a state. Okay, a state is like Andhra Pradesh, Punjab, Madhya Pradesh, Gujarat, whatever state it is. And if I have 10 stores in each state, and if I store the state in one place, so if there is a query that is trying to find what are my sales in Gujarat, or what are my sales in Tamil Nadu, so what I'm going to do there? So if the data is not duplicated, I need to go to another table, join the state, and then get the data. But if I put the state also in my dimensional table, that means I have to populate the state for each and every attribute. For each and every store, I have to populate the state. I think I have an example for that here. If I see this quickly, let's see. I don't have it here. I'm sorry. Okay, that's fine. I thought I had an example here in this slide deck. Anyway, that's fine. So basically, what I'm trying to say here is, so you will have a denormalized dimensional table. That means those descriptive attributes will be repeated. There's redundant data in the dimensional table. Okay. So I hope that is clear now. Okay. So let's move on. And before we move on, let me stop the recording here. And then we'll go back so that it's already 40 minutes. I missed the clock here. Okay, we're coming back. So let's go a little bit deep dive here. What is a fact table? What is a dimensional table? And then how they are built and all that. Okay, a fact table is one that will have the measurements, the business measurements, and mostly these fact tables are numeric. Majority of the times there will be some descriptive attributes, there's no question about it, but mostly numeric values and then the keys. So what we're going to do here is, when you're designing a fact table, we want to define the grain of the fact table. What is the grain? The lowest level of detail that you want to store in the fact table. Again, depending on the level of detail you want to store, it is going to dictate the size of the fact table. So let us say I want to store my sales by transaction. Obviously, it is going to be too many. But if I want to define my grain, I want to define the grain as sale by the store per day, or sale by the store per shift. Then automatically you are grouping some of the sales as one transaction, and there's going to be at that level you're storing. So the problem is, if you're storing at that level, store sales by store by day, that means if I want to go down if I want to see what sales I have done in a given hour, you can't generate that result. You can't generate that query. If I'm saving the data, if I'm defining the grain as a sale by transaction, that means if I have that lowest level of detail, then I can easily aggregate at any given point of time. So that's why I recommend strongly to define the lowest level of detail that you would like to store. So even the business doesn't want it, but you store at the lowest level of detail. And let us say business is asking, I am always going to run my reports by daily sales. I'm not going to go below that. So even that is the case, you store the transactional level, and then you create an aggregated level by day, and then people run the queries on that aggregate level. But tomorrow, 2 years down the road, if business decides, okay, I would like to see what sales that are happening by hourly sales. So if you're starting with data warehouse at the daily sales as our grain, then 2 years down the road, if somebody comes and asks, I would like to see hourly sales, you cannot give that data because you have not stored at that level. Okay? If you want to go back to that level, you need to go back and reload all the data for the last 2 years by the transaction level, and then you redesign the whole thing, and then you can give it. Or you have another choice at that point. You can tell to the business, look, our design is not to that level, and then you have to say that from this point, we can store sales by hourly so that we can have the analysis by hourly, but anything in the past, there is no way you can do it. Okay, so there is a way you can manage the request, but if you start at the lowest level based on the business that you're dealing, then it's easy for you to manage in the future requests. Okay, so that's why I will say the grain of the fact table is always the lowest level as possible. Okay, so process event produce the fact table. Again, it's a business process event is going to define what is going to go into the fact table. Mostly it's a numeric and additive. Derived facts are included. What is a derived fact? Let us say I have a sale transaction. Like the example that we have seen before, you have a cost, you have a sale. Okay, so you have both of them. In order to derive the margin, you can calculate what is the margin. So this is my cost, this is my sales. Difference of that will give my margin. What am I making? Am I profit or loss? Okay, what is my margins there? So this is a derived fact value. The margin is not there in the sale transaction, or it is not there in the cost transaction. So you are going to generate that derived fact value based on the transaction that happens on the fly. And you calculate that and store that in the fact table. Okay? So if you look at the OLTP systems, you would not store this margin. You will tell when the user is running a query, at that time you go and find what is the cost, what is my sale, and then difference is what you're going to project to the user, and this is your margin. But in a data warehouse, I am going to store this, calculate as I'm loading the data. If I have a margin, as I'm loading the transaction into the fact table, I have a cost, I have a sale. Immediately I calculate and store the margin physically in the table. Okay, so that is what I'm telling you. The batch window has significant importance in the data warehouse. Okay, you will be doing a lot of these calculations. You will be doing a lot of aggregations. You will be doing a lot of these manipulations to the data. When I say manipulation, you're doing these calculations to the data and physically storing them in the data warehouse tables so that your goal of quick response time, your goal of how fast you can deliver is going to be achieved. Okay, so it's very important that you're going to also talk to the business and find what all these derived facts, derived value that you're going to need, and then present those things. Okay, so foreign keys refer to the dimensional table entries. Okay, here the foreign key. Okay, every table in a database will have a primary key and a foreign key. Okay, I'm not going to go too much deep on this. I'm expecting you to go through, find if you don't have a database experience, go and read something. But every table will have a primary key which will define the table as a unique based on that key. If I'm using that key, I will have a unique results. Okay, but a foreign key is the one that is going to be linking to other tables. Okay, so as you have seen in the star schema a few minutes ago, you have a fact table in the middle, you have a dimensional table, so like 4 dimensional tables linking to the fact table. That means there will be 4 keys in your fact table that are going to be linking to those 4 dimensional tables. So there will be a key that is linking to the date dimension, there is a key that is linking to the store dimension, there is a key that is linking to the product dimension, there is a key that is linking to the promotion dimension. So these 4 keys are going to be combined or grouped, will be a primary key in your fact table. So that's why what we call as a primary key in a fact table is a multi-valued key. Because you will, for sure, you'll have multiple keys in your primary key of your fact table. Okay, so if I go to this example here, so this is a fact table. So you have a date key, customer key, product key. Okay, so these three combined is what is going to be a primary key for this fact table. Okay, so that is basically what I'm referring to here. Okay, so we'll leave it there and then we'll go to the next slide here and we'll see what the dimensional table is going to bring us. A dimensional table is going to give my descriptions of all different things that I do, okay, across the processes. If I have a customer dimension, I will have customer name, customer address, customer city, customer state, customer region. Whatever description that you would like to give, it will be there in the table. And those descriptive values are the ones that you are going to use in your analysis. If I have a region, then only I can do the analysis on regional level. If I don't have the region stored on this customer dimension, then you can never do the analysis on the region. Okay? If I don't have a quarter stored in my date dimension, I cannot find sum of my totals by quarter easily. I can do it, but I have to calculate, okay, first quarter is January, February, March, and then I have to do all that. So in a data warehouse, you are already pre-thinking that users will be doing analysis by quarterly. So you already do that quarters, store the quarter information in the date dimension. You already know that some users will be doing analysis drilled down by region. That's why you're going to put the region here. So whatever design that you're doing here, dimensional tables, all the attributes that you're going to have here is going to be dictated based on your business requirements. Okay, if nobody is going to ask you that there will be sales analysis done by region, you don't need to store the region here. Sometimes you might think, based on your experience, it's not taking too much space, but let's put it there so that in the future somebody asks if this information is available. Sometimes designers do that also. Okay, but just be cognitive that, so all these attributes that you have here in the dimensional table is what is going to tell when, what, where, these kind of questions going to be answered with those information. Okay, so we're going to introduce a new concept called surrogate keys. What is surrogate key? Previously we talked about primary key, foreign key. So now I'm introducing a new key called surrogate key. A surrogate key is an artificially introduced key only within the data warehouse environment. Okay, for every natural key that comes from a primary, the OLTP system, a natural key is an example like an employee ID, product ID. For every part that you have sold in the organization, there is a part description and also part number or part ID. For every vehicle that you sell, you have a vehicle description, a vehicle ID, or just like you have seen just before the lecture started, we said every textbook you have ISBN number. Okay, the textbook description, the textbook number like ISBN number, the unique identifier that you would like to use to identify a process, a product, part, customer, vendor, user, whatever it is. So those are the unique numbers that you're using in the OLTP systems. Those are called natural keys. We are going to bring them as part of your interface. We're going to store them in your data warehouse. Okay, the reason why we store the natural keys, because that is what business knows. If I give the surrogate key, business doesn't know what is a surrogate key. I am introducing myself an artificial key in the data warehouse so that it will benefit me as a designer to give a quicker results for the user, faster results for the users. Okay, so surrogate keys are artificial keys, stays within the data warehouse. It doesn't have any meaning to it. It's just introduced by the data warehouse designers. Okay, but for every surrogate key, there is a matching natural key. Okay, so let us say when I am searching, what is my sales in District 1 of Southern region in India. Okay, Southern region is an attribute, is a key. There will be a key for that. Okay, so based on that, you search and you go to the dimensional table and fetch the key that is linked to that record, and then for that record, you will also have a surrogate key created. Okay, so In the next slide, we're going to understand what is a surrogate key and why that is important for us. Okay, and in this dimensional table, like I said, it is a 1-to-m relationship. Okay, 1-to-many relationship with the fact table. Okay, for one record in the dimensional table, there will be hundreds of records in the fact table. Very simple example. I have a customer 1. You could be a customer here, 12867. I don't know the name here. You just type the number there. Or 2013 HT13121 is a key for that. I don't have a name there. Okay, so those are the student IDs. Okay, so if I have that 2013 HT13121, I need to remember that number when I'm trying to write a query. If that is linked to some student name, like whatever name it is, Swapnil or Nitesh, whatever it is, it's easy for me. So what are the sales, the transactions that is generated by Nitesh? What are the transactions that are done by Swapnil? It's easy for my business user to analyze that analysis. Okay, I'm not picking the numbers there. I'm just giving you. Try again. Put your names there. I would like to be personal here. Okay, don't give the numbers there. I don't like the numbers. I'm working in the data warehouse. I want to be as simple as possible. I would like to see you, even though I can't see you, at least name-wise. Okay, but anyway, so the numbers that they're giving me has a name associated to that. Okay, those descriptive names are stored in the dimensional table, and those numbers that you see, these are the natural keys. 20123, 2013 HT13121 is a bits ID. It's a natural key. Okay, when that key comes into my fact dimensional table, I will also assign a surrogate key for that. Okay, a surrogate key is a sequence number. For every dimensional table, you will start with a sequence number. You will keep incrementing. Every time a new record comes into the dimensional table, for that a new sequence number is created. Next sequence in number will be assigned and will be stored in the dimensional table. Okay. Sometimes you will have some null entries in the dimensional tables, and the date dimension is a very good example. So I think we have introduced some interesting topic by now here. You have a fact table which have measurements, and it has keys that has multiple keys embedded within that. Again, we should know why there is a multiple keys, because I need to join to these dimensional tables. If I have 5 dimensional tables, I have 5 different keys combined in my fact table to represent a primary key for my fact table. And if I have 10 dimensions surrounding a fact table, then I will have, my key will have 10 different keys combined will become a primary key for my fact table, but not each of these keys will be linked to a dimensional table that is connected to my fact table. Okay, so one-to-many relationship is very clear for me. A very simple example, I have a customer table, customer dimension. Let us say a customer is like, for example, I said, a student could be a customer buying product online. One of you could be a customer buying product. We all buy products online these days. Let's say online store. Okay, you buy a product, okay, and the sale is stored in the fact table. I am a customer. I am also going to buy a product, okay, and it will be also stored in the dimensional table, in the fact table, that there is sales transaction. Tomorrow you go and buy 10 products, and tomorrow I go and buy 3 products. So those 10 transactions will be stored in the fact table, and my 2 transactions also stored in the fact table. So just for you and me, there are 2 customers, the 2 entries in the dimensional table, but yesterday you had 1 transaction in the fact table, today you had 10 more, that means you have 11 transactions. For me, I had 1 transaction yesterday in the fact table, today I have 2 transactions, total 3 transactions for me, and total 13 or 14 transactions for you. So one-to-many, you have, you're 1 person, but you have 14 transactions stored in the fact table. And in my case, I'm 1 person, 1 customer, but I had 4 transactions stored in the fact table. That is basically what I'm trying to say. One-to-many relationship. For every transaction in every entry in the dimensional table, you have multiple rows in the fact table. Again, is it a rule that you have to have multiple rows? It all depends on the business. Okay, I'm just telling in general you have one-to-many relationship. In some cases, if I'm a user, I only have 1 transaction, I'm done. I have one-to-one relationship. But there is a possibility to have one-to-many relationships. Okay, before I go further, it's almost 9:30 for you, I think, or 8:30 for you. I'm going to quickly take some questions here. I've been watching it, not didn't drag me too much because it's not been answering some of the questions. But let me quickly go. Can you please repeat why it is denormalized in the dimensional tables? I think I explained that, Rajeshwari, by looking at your question already. But if it's still a question, if you want me to address that, type it again. Okay. Okay, we talked about why fewer fact tables and dimensional tables. Redundancy, we touched on that. If the number of attributes are too many, then the grains may be large. Am I right? Bindu, number of attributes will be too many in the dimension tables. Okay, but when it comes to the fact table, you won't have that many tables. Again, if you look at this very simple example, a fact table will have numeric business process values, attribute measurements. Okay, dimensional table is where you're going to store all the descriptive attributes. A customer could have 20 dimensional attributes that you would like to do the analysis on. So more attributes are there in the dimensional tables. So your question, you're mixing here. So number of attributes are too many, then the grain may be large. Am I right? The grain we're talking about fact table. The number of attributes in the fact tables are smaller in number. So that's why I said a fact table is a smaller and narrower table, but it will be very deep because it will have too many transactions. A dimensional table is a wider, but it will have less number of tables because again, less number of entries. The reason for that is a customer table will tell me all the customers in your business. A vendor table will only give all the vendors in your business. A student table will only give all my students in the table. I don't mix students with customers. I don't mix students with the vendors. I don't mix students with the products. I don't mix with students with the dates. So a student table will only have all my students in the table. So that means if my university has 2,000 students or 10,000 students, my student dimensional table will only have 10,000 entries. But it might be wider. I might have 100 columns. Okay, Bindu, I hope it is clear now for you. Again, I'm telling you, thank you for asking those questions. These questions will help me explain in a different way so that the points are clear for you. Okay. Again, I have to thank you, everyone who are posting the questions there. What is the difference between a measure and a fact? Both are same speaker. A fact, I'm using those terminology different places differently. I might be calling a fact. I might be calling a measurement. I might be calling the numeric values. It's all same for me. Ambarish, I did not understand the process given produce fact records. Can you please explain once? The business process. Again, depending on the business you're working with. Let us say you are in a banking industry. Okay, every deposit could generate a transaction. Every deposit a person makes into the bank is a transaction. Every person taking a loan is a transaction. So those are the business process events, I call them. Any of those events is going to generate a transaction that is a candidate that goes into the fact table. Okay, those business process events, the measurements, doesn't go into the dimensional tables. Let's make that point clear for us. Okay, that's a good question there, Ambarish. Rohit, calculated values along with the foreign keys are present in the fact table of right. Yes, all the calculated values are there in the fact table. Okay, again, do we create every one of them? It's a judgment call again, design decision. If you know very well the majority of the users are going to use the calculated value, then you calculate and store it. Every time you store something physically, even though I said several times, I don't care about storage, I don't care about how big the table is, I'm going to address that issue, but I'm also, behind my mind, I always thinking, well, if I store this, I need to also think about it is going to take space. It is going to make the table larger. It is going to have some impact on performance. But if it is going to be helpful in queries, I'm going to take the risk and then store it. Okay, so that is, every time you do that, you need to ask yourself the question and make that question answered if it makes sense. Okay, for sure, the calculated values are stored in the fact table and the foreign keys are stored in the fact table. Otherwise, you cannot join the dimensions with the fact table. Okay, Subhashis is asking, if for date dimensional table we have sub-dimension, what key for date do we keep in the fact table? Okay, you keep it the lowest level, date, time, stamp, period. Then from that point, you can aggregate to any date dimension that you would like to include. I prefer to store at the lowest level at the timestamp, date, timestamp, period. If I keep the timestamp of the transaction, I can aggregate to any level. Okay, that's the lowest level I would like to keep. Can you predict, conclude that down the lane after 2 years, what sort of keys will be mandatorily keeping in mind for fact changing trends? And Nirjar, I'm sorry, I can't answer that question easily because it is a challenging task. You cannot imagine what is going to be brought to you 2 years down the road. The business dimensions are changing, the business processes are changing. So you have to start with what you have, and you can assume some things and incorporate those things, but you cannot go too far. So we will have some examples as we go in the coming lectures. But for me, I have to start with what is currently there, and you can imagine some things, you can incorporate those things, but you cannot go too far. It's going to be you'll have infinite choices. It's going to be very difficult. Okay, so there is a chance that you can predict something, but it is very difficult for you to predict everything. Can you, okay, I answered that question. Chetan, surrogate key is a sequential key. Yes, I already talked about it. Surrogate key is a sequential number, okay, for each dimension. For each dimension, it's going to be different to surrogate key, okay, sequence. Surrogate key, yes, you are generating this a new key every time a new record is inserted into the dimensional table. Okay, there will be one-to-one relationship with a natural key with the surrogate key. Okay, is referential integrity present between the surrogate keys and the primary keys? A referential integrity is maintained between the dimension and the fact table for sure. A referential integrity is maintained because that is a database principle. We cannot move away from that. Okay, so I'm still storing all these in a relational database. So I cannot go away from my database, relational database concepts. I have to stay within those boundaries. Okay, so even though I'm creating the surrogate key, a surrogate key is linked to the surrogate key that is stored in the fact table. Okay, so we're going to give some examples. It will be more clear for you. Is it necessary that a primary key of a dimensional table should be present in the fact table? Yes, it is for sure. That is what I just said, a referential integrity. If you don't have that, then you cannot join the tables. A dimensional table is a denormalized. That means it can have redundant data. In that case, shouldn't be M2M relationship with the fact table. Okay. This is how it is. You won't have M2M again, many to many. I have many rows here, many rows here. That is a relationship. I'm not talking about attribute values. In Vinayaka, I think there is some confusion there. I'm strictly talking about number of rows in one table in relation with number of rows in another table. That is what M2M stands, many to many. Okay. I talked about one to many. If the fact table is clear, we generate it always. Yes, the surrogate keys are generated and new keys all the time. Surrogate key is not derived from the natural key. It is a unique number. It's a natural number, sequence number, just a number, let's say. There is no meaning to it. If this surrogate key comes, this is what I'm going to put. There's nothing like that. For every entry that is coming into a specific dimensional table, I start with a sequence and then keep incrementing by one. That's all it is. Why not we can use the natural keys as surrogate keys? Santosh Kumar, excellent question. We're going to come to that point. There is a reason why we do this. We're not mad. We don't want to add more work for ourselves. Okay, so there is a reason why we do this surrogate keys. I'm going to explain that. A good question, excellent question. The fact table holds a primary key of its own. Fact table primary keys is a group multi-valued key, so it's a multiple values combined becomes a primary key for a fact table. The surrogate key can be used for indexing in data warehouse. I understand this is a unique key at the low row level. Balaji, you're right. Every surrogate key will have an index in the dimensional table. Okay, there is no question about it. So we will talk about indexes in depth as we go into the second half of the course. Can we have total to subtotal columns? Okay, no. Total and subtotals, those things I don't store in the fact tables because there is no way you can store the total, cumulative totals and all that. Then you're moving away. You're building everything up front. We're not doing that. There will be some things that will be generated on the fly. So that is where the BI tools are coming into play, the business intelligence tools. So they take some responsibility and they do that work for us. Can you please explain again how dimensional table is shallower but has more attributes than the fact table? Again, Pawan, I explained that again. Very simple example, a product or a store dimension. I can say a store dimension could be a store name, address, city, state, that's it. Or I can expand that, store region, store country, store APAC region, whatever it is. You can expand as many attributes as possible depending on the analysis you would like to do. So it is going to be very large. But again, a product table or a store table will have a set number of attributes, a set number of rows. If I only have 1,000 stores, I will only have 1,000 entries there. I won't have 1,500 entries in my store table because my business has only 1,000 stores. If I have a dealer dimensional table, and if I have 1,000 dealers I'm dealing with, I will only have 1,000 entries. I won't have 1,500 entries there. Okay, so that's why I said it's a shallower, but it's a wider, depending on the business and the analytics that you would like to do. How can we fix the fields in the fact table? Fixing the fields in the fact table is not easy. That's why I said you don't go and change the data. If the data is stored in the fact table, it is frozen. That is another interesting point I would like to highlight here. Who is that? Anju. It is very important point for me because I never like going to change some fact values in the fact table that is done in the past. If I am doing that, that means there is a problem in the data coming through, somebody did a big problem, or I'm trying to manipulate the data or inflating some things or whatever it is. If a transaction happened in the past, it is recorded in the fact table, you don't touch it, period. There is no reason to go and touch that fact table record. If you're touching, that means there is something wrong there. Okay? That is the reason why I'm telling the testing is very important in the data warehouse. Okay, so if you thoroughly test and making sure the process is working fine, you don't have a chance, you don't need to go back and update something. Okay, I think we have taken most of the questions there. Let's move on here. Okay, the next one is a bus architecture. This is another thing that I would like to highlight in my course because we will have different dimensional tables, different fact table, and I would like to present all of them in a kind of a pictorial representation like this, where it's kind of a 2x2 matrix that will give an overview of what I have in my data warehouse. The rows will give all the dimensional attributes that I have. The columns will give all the measurements. And then the cross section will tell me that, okay, what I'm going to do analysis with. Okay, there could be a date and there could be no SSP. That means I cannot do analysis by date for the links. I cannot do analysis by date with impressions. but I cannot do. I can do the analysis by date, by visits. How many visits that happen in a day, by week, by month, and all those things. So just by looking at this bus matrix, I should be able to clearly tell what my data warehouse is also going to give. And I have seen many data warehouse designers don't build this bus matrix. They think it is not going to be useful. But for me, it is very essential. Every time I manage my data warehouse, the first thing I ask my team, if there is no bus matrix, I ask them to build one for me so that I put on my screen. Because I don't have time to go and look in depth what this data warehouse is going to give me. Just by looking at the bus matrix, I can tell what is my capabilities of my data warehouse, what all types of reporting I can do with my data warehouse, just by looking at a star schema. This is very still high level. In a star schema, you will still give all the attributes. It's going to be bigger picture. For this, it's going to be very smaller scale picture, but it gives me in-depth analysis of what my data warehouse is capable of. So try to build one, and we're going to give very importance for this. Keys and surrogate keys. A surrogate key, we talked about it. It's a unique identifier. It's going to be it's going to be a sequence number, and for every natural key, we will have a surrogate key. It's going to protect changes in the source system. This is what I think one of you asked. Why are we creating surrogate keys? We're creating surrogate keys because we would like to protect the changes that happens in the source systems. Okay, so the reason I'm trying to say here is, let us say I am a salesman. Okay, I was a salesman in northern India for 2 years. I've done the sales, and my sales ID is 1234. Okay, after 2 years, my manager shifted me to south. So now I am living in South India, and my ID is not changed. I'm just moving, relocating to a different location. My sales ID is still 1234, but my region got changed, my territory got changed, my new things have come. So what I'm going to do is, so my ID 1234, I have worked in this company for 2 years, and I'm going to work for another 2 more years. So now, if my bonus is, or my promotions are going to be based on my past experience, past sales generations and everything. Okay, so if I don't protect my changes, that means I was living in North America, North India, and I have done a 2-year sales, and now I moved to Southern India, and I'm doing another 2-year sales. And if I'm not able to protect my changes, that as soon as I move to Southern India, my ID is 1234. Immediately I change my sales territory from north to south. Then what's going to happen is, when I join the transaction to the fact table, I might not be able to match the results, because in the fact table, I have stored the key that is going to tell me that I am in North India. Now, after I move to Southern India, all the transactions that are happening from Southern India will have a new surrogate key, because I have changed some attribute there. I have changed the region. Because the region is changed, I'm creating a new surrogate key, and that is the surrogate key is stored in the fact table. Okay, so I'm sure there's a lot of questions coming for you in your mind, but I'm going to have an example there. But try to understand the simple point here. When these changes happen, if you want to protect these changes, and even though I worked in South India for 2 years, after 2 years down the road, I want to see what my sales that I was in North India. If I want to see that, I have to protect those changes. That is, if I keep the same ID 1234, okay, if I want to go and look my sales by 1234, I will pull all the sales irrespective whether I was in North or South. Okay, but I would like to differentiate that. If I want to differentiate, clearly try to see, try to compare, try to do some analysis, then obviously I need to protect those changes. Surrogate keys will give a choice, a chance for us to protect those changes. So allow integration from multiple sources. This is another point. Okay, so when the data is coming from different sources, okay, so you can create different surrogate keys, and then you can do the analysis on top of it. Okay, enable rows that do not exist in the source data, so you can create some data. You can create some measurements. You can create some of the dimensional attributes strictly for analysis purpose, even though they are not there in the source systems. So these are the keys that you can introduce, and then you can link to the fact records, and then you can do the analysis on top of it. So track the changes. I think this is the example I'm talking. Okay, so you're replacing text keys with integers. That is also another important thing. You know very well, IDs could be alphanumeric. Some numeric values like UN123 is an ID. So instead, if we store, because I said surrogate keys are unique and they're numbers, numeric values. There's no alphabets there. Okay, it's a numeric sequence number. So typically, as you know, computers, they work really fast when you are working with few numbers. As soon as you add some characters to that, it will slow down slightly. So that is also another reason why we would like to use surrogate keys in numeric values, so that it will be efficient in terms of retrieval. Okay. So now, what is the slowly changing time the dimensions? So this is another example that I was giving just a few minutes ago. So I move from northern region to southern region, and it could be a business decision for me. I don't care about this change. I just overwrite it. Okay, so that could be the type 1 change. I don't care about where I worked in the last 2 years. I just care where I am working today. If that is what you care about in your analysis, then you can overwrite that. You don't want to do the analysis based on historical change. Then it's a type 1 change. That means if that happens, you just overwrite the value in the dimensional table, you're done with it. A type 2 is you're going to maintain history. Okay? So the example I gave, I would like to know what I did 2 years before, and I would like to know what I'm doing today. I want to compare that. Then I have to do type 2. That means you're not going to overwrite the dimensional table. Instead, you're going to create a new dimensional record. When I'm creating a new dimensional record, I'm not going to change the natural key. My ID 1234 is going to still stay 1234, but I'm going to create a new sequence number. That is a new surrogate key. Okay, so that is basically an example that I'm going to give here. See here in this example, so I have my ID, customer ID 1552, and in 2005 this was ID, and this is the sale I did. In 2006, I moved to a different territory. Whatever it is, what did I do here? I moved to a different district. In 2006, I moved from a district 3 to district 31. Okay, so when this change happened, for this customer ID, 31421, this is my natural key, like 1234, like I said. For the same ID, same name, there is a change in the district from 3 to 31. So now I'm creating a new surrogate key. 1552 was before. Now I'm creating 2387. So now you see the difference. For the same 1234 ID like me, here in this case 31421 is a natural key. We're not changing the natural keys because this is what is there in the source system. So we maintain that by we introduce an artificial new surrogate key here. So now, tomorrow when I run a query, so I run a query, what is my sales in district 31? So I look at this value, find the natural key, find the surrogate key, and join this table. This table will have 2387. From starting 2006, you will not store 1552 anymore because your natural key is linking to this new surrogate key. So from that point forward, 2006 forward, anytime there's a new transaction comes, you're going to use this key here. So when I'm running a query, what is my sales generated when I'm in district 31? I find this key, join to this table, I find the sale of 1995. And if I want to find what is my sales in district 3, I go to this table, what is my surrogate key 1552, I join this table with surrogate key, I will find these 3 entries, and then add those 3 values, and it will project the result for me. You see the difference here. Now I come back with a different query. What is my sales for 21421? So I'm not talking about district. I'm talking about what is the sales for Jane Ryder. So if I have that query, so when I see Jane Ryder in this table, I have these 2 rows results. So these 2 rows will be joined with this table. So this join will give these 3 rows, this join will give this. So I add up all these things, and then my total sales for Jane Ryder will be summing up of all this. So now we understand the analysis. So why we do this? Again, it's a business need. Based on the business need, we are going to do this. So that's what type 2. Type 2 will generate a new record. Type 3 will generate a new column. So a type 3 is, you can always give at most one recent change. That's all you can preserve with the type 3. Okay. So I think this example is a very good example that you can take and try to understand. And this is another example that will give a little bit more detail, type 1, type 2, type 3 changes, how they are. Okay, the date dimensions, we talked about it. Okay, so date dimensions will be elaborate in every data warehouse. You will have a date dimension because we love dates, we like dates. Business people love the dates. They would like to see what they did here, what they did that day. So the date is essential for every data mart. And there are some other more dimensions that we are going to touch base here. Okay, so there will be dimensions that are called junk dimensions. Again, a junk dimension is the author tells is, there are situations in the source systems. There are a lot of attributes. Always remember that we're not going to translate every bit of data that is there in the source system into the data warehouse. Sometimes we leave some data behind. There are some flags that you would like to bring onto the data warehouse so that you can do some analysis. Then those things that doesn't fit in one of these dimensional tables, like a fact, the customer, vendor, promotion, those are dimensional tables. So again, I'm telling you, you don't mix the dimensions also. So you clearly define a dimension, only related information is stored there. A customer is not mixed with a student, a customer is not mixed with a dealer, a customer is not mixed with a vendor. Okay, so you got to be very clear. So there is another thing we call it the degenerate dimensions. So degenerate dimension is like you're going to store some numbers like the order number, sales number. Those things are stored directly in the fact table. Even though it is not we don't, like I say, order number, where are we going to keep this? It can't go into the customer table, it can't go to the, any other dimensional table. And then should we put the order number? Should I put it in the fact table? But fact tables are measurements. Order number is not a measured value. So where do we put? So that's why the author says you can put this in a fact table, and we call that as a degenerate dimension. We keep it there so that we can do some analysis with that. Okay, so in aggregates, we're going to touch elaborately on aggregates in the coming lectures, but just remember that. So we spend time building this fact table, and we spend extra time building the aggregates. Again, aggregates are based on different hierarchies that you have. I might build, let us say I have a customer table. I might build an aggregate by region. I might build an aggregate by district. I might build an aggregate by country. Okay, again, those decisions you're going to take based on the business need. Don't, just because you have aggregates you build, don't build aggregates for everything. There should be a business reason to build an aggregate, and the aggregate tables are built over the fact tables. Okay, then aggregate tables for sure are smaller tables than your original fact table, but you build aggregate tables and you use these in your analysis and your analytics. In fact tables, we talked about this clearly. I don't know what to elaborate. Again, I just talked a little bit detail here. It's the same concept. And the example here, you can go through this, and again, the next lecture when we come back, we can talk about it. This is a simple, very simple example. You should be able to understand. Like I said, you have retail sales. The grain is the point of sale line item. I think we already talking these examples as we go. You have a date, store, product, and promotion. We already know by looking at this. Now we have understanding how these tables are linked. Fact table is the sales fact table, and dimensions of this. By looking at this, you have what are the different fact values you have here, and you can see these are the fact values, and you can come up with the different dimensional attributes, and that is what this example is talking about. What are the different possible date dimensions? Day of the week, day of the month. You can come up with anything. Holiday, fiscal year, fiscal month. You just name it. You will have it here so that you can do the analysis. Okay. So possible attributes here again for product. What are different product attributes, package types, package size, department, brand, all of these things. The brand is going to give an example. What kind of brand analytics that I can do? Okay. So what are sales for this brand? Especially in our organization, we have different brands. We make tractors. We have a Pace product, New Holland product. Okay, a lot of other products. Okay. So just give me 1 more minute, and then I think this will complete this. These are different examples that we have. The store dimension, you can see region, state, manager, district. All of this information is stored in the store dimension. Okay. And we talk about factless fact table, and in the next lecture. So I'll stop right there and take a look at this example, the similar examples you can go through, and then conformal dimensions we will go talk in the next lecture. Okay. So we will stop right here. Again, it's 9:32 here. It's almost 9 o'clock for you in India. Again, thank you for joining today, and I will stop the lecture right now. Those of you who had to leave, you can leave. But I will take up the questions that came up afterwards. We will touch this factless fact table and degenerate dimensions extensively and conform dimensions in the next lecture. Okay. Again, thank you for joining. Let me stop the video and come back in a minute. Okay, that's good, so that I don't miss it. Okay, Santosh Kumar, I know you're asking what is conformed dimensions. We're going to come to this point. We're going to elaborate this in the next lecture as we ran out of time. Okay, we talked about subtotals, and that's just clear. Can you explain how dimensional tables are? Okay, we talked about that. Can you explain again how the dimensional table follower? Okay, we explained that. How did we fix the fields? I said we don't fix the fields in the fact table. We don't change the data in the fact table, the historical data. So we're going to keep them as it is. Bhu Balachandran is asking, can we have two fact tables, one storing main info and another storing breakdown level detail? Okay, that is an example that we touched is aggregates. Okay, so you start the lowest level, the actual fact table, and then aggregate level, which is a little bit higher level. Okay, I think that's what you're trying to explain there. So if that is not the case, ask the question again, Mr. Balachandran there. Okay, we talked about that. Being a data warehouse designer, how do you take care of it? Nirjar, I'm sorry I didn't. Okay, looks like I answered your question. So thank you there. Okay, good. That's fine. Didn't get what is the conformed dimensions. Like I said, we're going to cover this in detail in the next lecture. But in any simple terminology, a conformed dimension is a dimension that can be shared across multiple fact tables. Okay. As long as you have a fact dimensional table that you can share across multiple fact tables, then you can call that as a conformed dimension. Okay. We'll elaborate that in the next lecture. If we introduce a new key in the fact table, how the existing entries are affected? Anju, that's what I said. There is no way the existing entries are affected, because, see, that's what I was telling. Example here. Example is very clear in this case. This is the fact table, as you can see here, and when we added a new record here in the dimensional table, and for the same natural key, and we have introduced a new surrogate key. And then when a new sale comes from that point, so what we're doing is we're introducing a new key into the fact table. We're not putting 1552 anymore in the fact table. For every transaction that comes after January 2nd, 2006, so you will have the surrogate key is 2387 here. Because this is a history, this is no longer active. As you can see here, effective begin and effective end. This surrogate key is no longer active. This is the active surrogate key that has the current information that is relating to that particular customer. So I have to store, based on that value, I'm going to store it. So that is another thing that we're going to cover in the next lecture. Let us say there is a transaction come from the source system, and you go and look at it, what is your surrogate key, and then link to that surrogate key and put it here in the fact table. Okay. So every time a new key is introduced in the dimensional table, that surrogate key is the one that you're going to be stored in the fact table. You're not going to store the historical one, because historical surrogate key will be stored for all the sales that happened in the history, in the past. Okay. If the surrogate keys are sequentially generated numbers, then why not keep the natural keys? A sequentially generated number would not help better than a natural key. Again, Aditya, I explained, I think most of the organizations, most of the database designers, the natural keys, they keep it the numerics like this. But I have also seen many database designers with the natural source systems. The IDs are like not only numeric values, they have alphabetics. Sometimes completely alpha character is a numeric key. So the character attribute is a primary key in some of the databases. So by making sure for every entry we will have a numeric key in the data warehouse, we are eliminating completely character-based keys, completely eliminating. Okay, so that is what the concept here. A surrogate key introduction into the data warehouse is mainly to improve the performance when we join this stack to the dimensional tables. Okay, another point I would like to highlight to you is a dimensional entry is created only when the surrogate keys are created. Don't assume that surrogate keys are created as and when data comes into the staging area. Okay, the data that when it comes to the staging area, it will be probably what the natural keys you have. That's all it is. So when you are storing into the dimensional table, that is when you are generating these surrogate keys. Okay, we're going to talk about this in detail in the ETL lectures, but as you're asking the question, I have to explain that to that level. Okay, hope it is clear for you, Aditya. So Nirjar, as we all know that SAP HANA is a buzzword, so using that for designing your data warehouse, will it change the designing? As it a column-based? For sure, yes. You're right. Things will change, but the SAP HANA it's a completely they call it memory based, in-memory based. So it will be everything stored in the memory, so things will go really fast. And I'm not going to discount that everything will be there, but you still have a backend BI, so you just play accordingly. Okay, there is no question about it. Then we have nested star schema dimensional model and also act as a fact table. Nested star schema, Rajkamal, I'm not able to understand what you're telling. But you could have an extension to the dimensional table. We normally call that as a fact, what we call a snowflake schema. We're going to introduce that in the next lecture probably. But I don't think there is room for nested star schema. Since we are talking about tables, relationships, here, does this mean that we can't use NoSQL technologies in the data warehouse? Vipin, I think I explained to you or explained the way in the beginning of this course. I said data warehouse is going to be built on top of a transactional system. If you don't have a transactional system, there is no data warehouse. If your business doesn't have a transactional system, if there's no OLTP system, you're not going to build a data warehouse on the fly. A data warehouse is built based on your needs that your organization have a transactional processing system, and you want to do some analytics, you bring the data into the data warehouse. So in order for us to do this analytics, it's easy for us to put them in these facts and dimensions. Okay, so if the source system is not a relational model, it could be a network model, it could be a hierarchical model, it could be some other model that you have, NoSQL technology. But when it brings to the data warehouse, you want to do this kind of analytics, try to translate the data. As you understand the concept, it is a fact table and measurements. Okay, it doesn't need to be SQL in the source system. But you try to translate what data you have, translate the data, and bring it to the data warehouse in a fact, which is a measurement. And then all the dimensional attributes that you're going to use for your analysis, you're going to put them in the dimensional tables, but your data warehouse could be relational tables. It doesn't need to have a SQL-based database on the transactional side. So you work with the source systems and they will give the data the way you ask, and then you insert in your relational tables and build these relationships and then build your data warehouse. Bipin, I hope it's clear for you. Okay, got it, that's good. Are dimensional tables created as exact replica of existing basic data tables in the database? Or are they created as and when required? So dimensional tables, as you can see here, customer, so it is created based on the data that you have in the source systems. There could be some data that you generated based on the data you got. There could be some data business has inputted into this. Okay, so there, out of this dimensional table, there could be 10 attributes coming from the source system, 2 attributes you have generated by yourself. A very good example here. So you might have got effective date, and the end date is when there is a change. And then you could generate this end date here, and then the end date here it will be forever. Let us say there is another change from 31 to 21. As soon as this is changed, you pick the whatever the end date that you have that day, and put that effective date, and this will be end date. So basically, these 2 dates you're not getting from the source system. You're generating on the fly. Okay, and there could be some other attributes like this, which will be inputted by the business. They're not there in the source system, but you are introducing yourself for your analytics. So to answer your question, Tiruthiga, it is a replica of what you find in the source system. Also, you might generate your own some attributes based on characteristics, or you input some data by the user. User also can input some data. Business user can input some data if they would like to do some analytics in the data warehouse that is not there in the source systems. Okay. Abhitesh is asking, let us say my customer has different subject area of research. A number of subject area may vary for different customers. How do we manage this in the dimensional table? Customer has different subject area of expertise. Okay, again, Abhitesh, I think we have to take a look at this clearly here. We have a customer, and they have different subject areas of expert. Okay, so you got to be clear on that. Do you want to create subject area of expert as one of the dimension? If it is a lot of subject areas, and then customers could be another dimension, and then based on that you can relate. But again, you could also have customer, all the subject areas in one, and then the problem with that is if there is another subject area that you want to add, you can't add to the same entry there. Okay, so we need to play with that a little bit and then come up with a design there. Chetan, but you can keep the regional IDs to avoid surrogate key, right? If there is any region dimensional table is there. I don't think there will be any regional dimension here because region will be part of this. That means that's it. There's not going to be another regional dimension. Okay. So again, look at this. You try to mix. Make this again. Just because you're creating a star schema, you don't bring region as one dimension, customer as another dimension. All the related information I try to put in one dimension table. Okay, so you need to bring all the related dimensional attributes into one. Don't create multiple dimensions. Okay, if it is related to customer, put it in the customer. There is no reason to create a region as a separate dimension. Can a customer key and customer ID becomes a primary key? In case of dimensional tables, the customer key and this one, in this example here, customer key is the primary key because this will be unique. Okay, this will be a secondary key. That's all it is, and this is linked to the this is not linked anywhere, but it will be a secondary key, and you could have an index on it because you'll be searching on it. But this will be the primary key for me. So in this case, the primary key is the combination of these 3 attributes. But in this case, the primary key is just the customer key. Umesh Kivar is asking, how do we build the star schema using ETL? We're going to talk about that, Umesh, in the coming lectures. Okay, so give me some time. So we're going to elaborate that. And snapshot and cumulative snapshot, cumulative fact tables. Yes, I didn't touch that point, but again, it's a fact table. Cumulative is, you have lowest level, then you build another high level where you're accumulating some data based on some attribute, and then you store the data at that level. So you have cumulative fact tables. Please, can you give one more example for degenerate dimensions? Yeah, we'll talk more examples in the next class. Manoj, let's stay right there. Customer key and becomes a primary key. I think Raghava, I just explained, this customer key is the primary key for you in the dimensional table. Suresh, you said not able to hear. Hope you're able to continue hear me. Sorry, I didn't see that message. Can you explain hybrid SCD? Siddharth, again, I skipped the slide. It's just a combination of both type 2 and type 3. That's all it is. Combining both. If we introduce a new key in the fact table, all the existing entries are affected. We're not affecting any existing entries. That's what I said clearly. We're not going to go back and change any of these values. Nothing. No way. There is no need to change, because as I said, if you see my example, if I am asking about Jane Ryder, okay, I have gone to this dimensional table. I would like to see what is the sales generated by Jane Ryder. I will find these two entries in the dimensional table, and these two entries will be getting joined with this. When I join this entry with this, I get these 3 rows. When I join this entry, I get this row, so I get total sales. That's all I need. I don't have to go back and change all these entries with 2387. It's the same thing for me, whether I change this or not. Okay, so that's as simple as that. Hope it is clear for you. I'll explain one more thing. So the reason why we created a new surrogate key here, because we have assumed whenever there is a change in the district, we have to create a new entry. So that is a type 3 dimensional change. It's a type 2 change. Okay. So let us say we have assumed even if a district is changed, we're still going to say type 2, type 1. That means, so there is a new record coming for the dimensional entry, and 31 is here. We're not changing anything. That means the Jane Ryder has moved from district 3 to district 31. We just overwrote the record. That means when a new record comes here, you will still have 1552. Okay. So then what's going to happen is you can never go back and see what sales I did for district 3 versus district 31. You're done. If you're saying for a district changes, you're not using type 2. That means you're using a type 1. You're overwriting this. That means there is change in the district 1. For a district field, that means the customer, the salesperson has changed from district 3 to district 31, and you have not captured the change, and you just overwrote here because that is what the operational system did it, and you overwrote it. That means you will have only one entry in the dimensional table, 1552. Tomorrow there is a sale comes, it will be as 1552. Another sale, 1552, like this. Okay. So tomorrow you want to run a query. What sales I did in district 3? You don't have a district 3 here in this table. It is overwritten by 31. So you will not get any results. It's 0 results. But if you search what sales I did by Jane Ryder, I will get the total sales just like you did. Okay? But if you want to find what sales I did in district 3, I will not be able to give it. And that is also another point. I think Anju, somebody asked me, so tomorrow, 2 years down the road, if I want to add this, so there is no way you can go back and correct all this. Because if I change this 31 and I started entering all these values, all these entries from 2006 to 2014 now, I have same entered 1552, and now somebody comes back and say, I would like to change, I would like to preserve history. You can only preserve history from that point onwards if you made a decision. But if you want to go back and change history, it's going to be a nightmare. Okay, we need a surrogate key because dimensional tables are denormalized, right? No, that's not the Virendra, that's not the only reason denormalized. The reason why we create a surrogate key, one of the main point is performance because we're creating a numeric value. The second important point is the example that we're talking here, preserving historical changes, because that is going to really help the business drive some decisions. If it is not going to help business drive the decisions, you don't have to create type 2, you know. So I hope it is clear for you there too. So Kritika, so you're asking, are dimensional tables created as exact replica of existing base table? I think we asked about this already, we explained that. Which is better out of star schema or snowflake schema? Prashant. I prefer star schema, but if there is no choice, sometimes I go to snowflake schema. It's just an elaboration to that, but I don't start with the snowflake schema. I will start with star schema, and some occasions based on a lot of performance issues, something like that, I will expand it to snowflake schema, and we'll touch that in the next class. Yeah. If a new dimensional table is added, then yes, if a new table is that's a good question, Anju. If a new dimensional table is added, so that needs to be added in the fact table. There's no question. There's new key has to be added. Let us say now here in this you have a date dimension, customer dimension, product dimension. Tomorrow you have a promotion dimension coming here. Okay, so if you have a new promotion coming, let us say in 2015 January we introduce a promotion concept in our business. Till that we don't have promotions in our business. So now we are introducing a new promotions. So what I'm going to do, you will have a new key here called promotions, okay, and then you will have a new dimensional table called promotional dimensional table. So every entry that comes from that point forward, you will have also a key for the promotion, okay. For all other entries in the fact table, it will be undefined promotion key. You will have an entry in the dimensional table for promotion called undefined, and some surrogate key, and that is what you have updated for all historical data in the fact table, because there is no promotions before 2015, so there is no way you can assign it. It's because the concept itself is new for your business, and you're introducing it in 2015, so it will be only available from 2015. All our historical data will be undefined. Okay, that's a good question, Anju. Very good question. Hope it is clear for you. And you're still online. I'm sorry. I'm not checking you. Okay, you're still online. Krishna is saying, if the natural key design is changed from a single primary key to a composite key, how does this affect the design of the dimensional table? The natural key design is changed from a single primary key to composite key. Okay, again, Krishna. Like I said, the primary key in this table is just a customer key. I'm not going to include this customer ID to this because there's no reason. Okay, this itself is a unique. A primary key just needs to be unique. Okay, for a dimensional table, you could have a composite keys, but most likely just a surrogate key could be your primary key there. I'm not telling you can't have it. You could put a composite key there. That's fine. Multi-valued key for your dimensional table. I'm not telling it's wrong, but there is no need. Once a transaction is recorded in the fact table and then the customer requests for some discount, and how the sales amount has changed for that transaction, how will it affect the fact table? Yes, Abhitesh. If there is a new discount coming, okay, so it will be a new transaction generated. Let us say we have those things in our business too. We have a sale, and then let us say we miss some discounts giving to the customer. So what we will do is we'll generate a new sale with a discount amount. That's all. We're not going to go and update the original sale because the original transaction is done, deal. We're not going to change that. Any discounts that we're generating in the future, because we missed something, we forgot some calculation, we're going to generate a new transaction, new sale transaction, which is not actually a sale, but it's a discount sale. We're going to give discount. It's a negative sale. So then you have a negative entries will be in the, that true negative entry will be here. Okay, that's how we are going to give. So we're not going to go back to change, update something, because this transaction here has a 1,798, and let us say there was some miscalculation and he's supposed to be charged only $1,700 or 700 rupees. So $98 to be given credited here. So the one way to is go back and update this directly. That is what normally the operational system will do. But in case of data warehouse, what we do is we generate $98 of credit, minus $98. So when we look at the sales, so it will be same as what you see in the operational system. In our system, we have around 3,500 subject areas. Should we create a new dimension for subject area? Yeah, I would prefer. I recommend creating a new subject area dimension. So once transaction is recorded in the file and a customer request, okay, I talked about this updation already. I think I explained that to you just now. Good, Anju. Good. Thank you. As long as it's clear, that's all I care about. Excellent. Good job. That's good. Again, thank you for asking the question. That's I had to ask that. I had to tell that again and again. I want more questions so that it will be more. Again, I'm telling you. I know some of you might not like me, but asking questions, you bring more from me. Bring out more from me. You know, that's what I like, because I would like to think out of the box, come up with different examples, different scenarios, so that it makes more sense for me, so that we understand the concepts. If I have changed the keys in the composite key, then will this require a change at the dimensional table? Yeah, it is. You know, I don't understand, Krishna. You're not going to change dimensional key here, because this key will be the same and you're just adding a new value. Tomorrow you're going to add a new key. That's what you're asking. You know, don't worry about creating a new key part of this primary key, because if you have a new key value, new whatever it is, you can just create an index on it, because that is what you're going to use. Mostly these tables are joined by these surrogate keys, as you can see here. Any other keys that you're having here in this table, it doesn't have to be included in your primary key. As long as you have an index on it, your access will be faster. Okay, don't put yourself that I will have better performance if it is part of a primary key. I know that is what we study in a database. If it is part of a primary key, it will be faster, quicker results. You know, I can give a faster result even if it is not in the primary key, as long as I have an index on it. Okay, so you would be surprised on this table. I'm telling you, we'll have an index on this for sure. You'll have an index on this for sure. You'll have an index on this for sure. You'll have an index on this for sure. And you'll have an index on this for sure. Probably I might not have an index on this. Or I might have an index in gender, a bitmap index on this. So just by looking at this, I have 10 columns or 8 columns. I already got 6 or 7 indexes on this. So you might be thinking, PC, are you crazy? Yes, I am crazy. The reason why I create that many indexes, so that if tomorrow you come and try to retrieve a query by district 31, I can give the data like this. Okay, so that is the beauty of this data warehouse. You design in such a way that, you know, it will take space. When you're creating an index, you are adding more space on the database. You're occupying more space, but at what expense? To give faster response. Okay, so I think Krishna, if I understand you very well, I'm reading your question well. I think you have this concept that if I have a value in my primary key, I'm faster because it's unique. Don't think like that. In a data warehouse class here, you know, you will have ton of indexes. Okay, so you know, so you just create a key and index on it. That's all you need. It doesn't need to be part of your primary key. In OLTP systems, yes, you're right. You know, I'm not OLTP designer here. Okay, in OLTP they do crazy things, in my view. Okay, so I don't care what they do. So in OLTP, you're right. They do put it in the primary key, so that they assume you know, it will be faster. Another reason they also do there is they have something in their mind saying that if you have too many indexes on this table, it will have a performance drain for them, performance issue for them in their design philosophy. Okay, but I think they're coming out of that design philosophy, and people in even OLTP systems are creating a lot of indexes. But it's what it is. You got to plan accordingly. But I agree with you, Krishna. If you're comparing with OLTP, yes, in OLTP designers will do that because of their philosophically their way of thinking is different. But in case of data warehouse, I think differently. My design concepts are completely different than OLTP. They talk more about normalization. I talk more about denormalization. They kick me out if I'm in their meeting room saying, I would like to introduce this redundancy. They don't like that. I'm talking completely opposite of their philosophy. Okay, so I think you're right, Krishna. I hope it is clear for you now. Good, Abhitesh. I think you're also clear for you. That's good. Looks like we covered all the questions. I think very good questions. Thank you. Again, I really appreciate asking that question, Krishna. This is what I like. It needs to be clear because the philosophy in OLTP is completely different than the philosophy that we talk here in the database, data warehousing. Because as you see here, yeah, it is good to have it, put it in the primary key so that it will, you're taking advantage of primary key constraint, the database principle. Okay, yes, that is right, but you don't need to do in the data warehouse because you have index anyway on this, you have index on this, so why can't we just create another key and index on it? You're done with it. You don't have to go, anytime you change the primary key, if you remember, Krishna, you have to regenerate the whole dimensional table. It's not an easy thing. If you're changing a primary key, it's a big thing in the database. Okay, changing an index is a very simple thing. Okay, for me, I would like to manage simple things because I don't want to go back and regenerate, refresh the whole dimensional table because I changed my primary key. In other words, rebuild it. Okay. So I hope it is clear for you, Krishna. I'm probably not expressing correctly here. I think what I'm trying to say here is when I say rebuild, let us say I have only this as a primary key. Tomorrow I would like to add this in as part of my primary key, so which means this entire table, if this has 100,000 records, I have to put that to a temporary table and then change the characteristics of this definition of this table to primary key of this, and then reinsert all the data from the temporary table into this. This is what happens when you're changing a primary key attributes of a table. That is how the database works. You can't just like on the fly go and change the add a new attribute to a primary key. Okay, so it is what it is. Database goes through all these steps. Okay, whereas if I add a new column, you don't have to go and do all these things. You just add a new column, new index, keep adding the data. That's all it is. Okay, so I think we have covered all the questions, and if you have any questions, if any one of you would like to speak up, even now, I have an option. I can unmute you. You can ask the question. Anybody would like to speak? Suresh, you're still on the call. Any comments from you?
No, PC. I think things are going great. I don't see any comments. Things are good. I think we are on track.
Okay, good. Like I said, we'll be in touch with you. I will call you sometime. We will discuss possible options. I would like to ask you now itself. Can you propose a topic that you're comfortable, you're confident that you can present to the class? So that we can include that sometime during the course of this semester. Pick a topic, whatever it is, from our handout, and if you are comfortable, you can present, put together some slides and share it with me, and then we can review and then go from there. Okay.
Sure, PC. I think let me work something on that in this week. I think by Wednesday, I think should be able to share you something.
Yeah, and come up with some good examples in your experience in that topic, and then we can plan and schedule something, and then you can drive the lecture, one of the lectures in this semester.
Sure, PC. Thanks for that.
Yeah, in the last, I don't know, not last year or last semester, when I taught first time, I had one student from, he joined, I think, from Saudi, I think. There's a student, he was from Saudi Arabia, and I don't know, somewhere. He's not from India, but he was connected. He was a distance learning student for BITS campus, Dubai, I think. I'm sorry, Dubai. And he was a research student in one of the university, and he was doing a research on what is that on this data warehousing, one of the sections of data warehousing. So he presented his lecture, his research topic in one of the lectures. So I really appreciate, because you can bring in some of your experiences and add value to this course. So that's what I would like to do. And like I said, just come prepared, and then for sure we can have offline discussion. You have my email address. You can directly be in touch with me, and then we can go from there. Okay.
Right, PC.
Thank you, Suresh. Okay, so Bindu is asking another question. Are we archiving the fact table? Yes, Bindu, for sure. Yes, we have archive. Otherwise, we can't. Like I said in lecture 1 or 2, I said we can't keep growing this table forever. There is a rule that we put in the data warehouse, and we archive. And based on, again, there are rules we incorporate. For example, in North America, I only need 7 years. Beyond 7 years, I don't really care. So I put a rule saying that anything that is beyond 7 years, I archive and take offload from the database. Okay. So again, we'll talk about those things in depth, so don't worry for now. But for you, for right now, the answer is yes, we do archive. Okay, but there is not much archiving for the dimensional tables. They're not going to be big. They're going to be, like I said, the biggest dimensional table I've seen was 1 million records. So, not million, I think it's 8 million records. That is the biggest dimensional table I have seen. So even that, we didn't have to archive anything, but most of the dimensional tables we don't archive, because we would like to preserve historical data. Because, like for example, in this, if I archive the data which is beyond 2006, then I will never be able to do the analysis, even though I have used surrogate keys and everything. So dimensional table archiving, it doesn't make any sense, but for sure a fact table archival is in scope, and we'll talk about that. Okay. Okay, thank you everyone. I think that was the last question. Good night, and see you next week. Okay.